Hi everyone, it's Danilo and we're gonna continue creating our project, our game of life in Java. So in the previous video we stopped here and the problem was that the grid that we want to show is too big. It could be from 0 to 1000 across and vertically. So the thing is that I came up last time was to draw this to use this red camera that would capture only a part of the actual grid. So it could be a good idea actually, and the way we can really work with it is to say have some coordinates for the top left corner and for the width and the height of the camera. So let's say this would be 500 to 500. This would be the top left corner, and let's say the width and height would be 20 south. That way we would capture 400 south, because 20 times 20 is 400. And we also want to have the ability to zoom in and zoom out our camera. So we basically want to be able to make our camera larger and more little. So I think it's also possible, but we should understand that the actual width of the camera, actual width of the component that the user will see, should be constant. Let's say this would be this width would be constant for user, and it should be, let's say, 600 pixels. So this will always be 600 pixels no matter how large the actual grid was showing. So we will actually make we will actually change the size of the visible cells depending on the zoom in and zoom out. So let's try to do that. Let's try to do that in code, and we stopped here. And the way we could do it is to create a private class that would be a camera. So private class camera. Or maybe we want to have it as a public class, but let's leave it as private until we actually use it outside the scope of our game component class. So camera, and as I said, we want to have coordinates of the top left corner. So let's say int x would be initialized as, I don't know, 250, or we can leave it as it is, as private variables, private int x, private y, int y, and also we want to have width and the height. So width and height. And the very convenient thing about this camera is that we can actually work with private variables inside our game component class, because when we are using inner classes and or nested classes, we have the ability to change private members of the inner class of our class. So we may actually want to leave it as it is, or we can also create a public constructor that would be only visible inside our game component because the class itself is private. So we can make things easier by using IntelliJ IDEA to create a constructor with all these variables, and there we go. So let's say the game component will always have a camera, so private camera, and we will initialize it here as a camera is equal to new camera, and this should depend on the grid size. So let's say the X value, let's say we want to have it on the middle initially. So how can we achieve this? And also we can say that by default we always want to have 20 by 20 20 by 20 width and the height, the number of cells that we actually see. So to achieve that, we want to get the center, so this would be 500, and the X value and the Y value would be 500 minus 20 divided by 2, this would be 490. So if this would be 490 by 490, then this would be 510 by 510. So this would actually be in the center. So to make it more generic, we want to use it like this. So basically we can say grid, or we can even say int size is equal to grid dot get grid cells dot length, and this is the size of the grid. So this would be 1000 in our case, because initially the size is 1000 and this is the length of the array. So we have that size, and now we want to use that size. And how we want to use it? Let's say we create let's say we create a static member, public static int default visible cells is equal to 20. What's the problem? Inner classes cannot have static declarations. Yeah, we may want to use static class instead, because turns out I've never really seen that static members are not allowed inside a inner class. But we can always use it in the outer class, like here, and this will not be the problem. And maybe it makes sense to disallow it, but we can always use it just here. So anyway, let's say default visible cells, and how we're gonna do that? As I said, we should use size divided by 2, because 500 is 1000 divided by 2, minus default visible cells divided by 2. And the same should go for Y value, and the actual the width and the height would be default visible cells. So there we go. And actually we now have the set it up camera, and we can actually use it. One more thing we want to do is to have the actual width in pixels of our camera. So how are we gonna achieve it? I think it should also be a member variable, like private, I guess, what would it be? Int pixels per, or no, we want to have a constant size, so we can say that the X value, the thing is that I'm concerned about, because camera should not necessarily be a square, and we should somehow denote it here. Private int pixel width should be a constant, that is, or pixel width, let's say 600 pixels, but how do we know about pixel height? Because it depends on the actual height, the actual relationship between width and height that a user will set up here. So I think we can just leave it like this, and the height will dynamically change depending on the height then that the user will input here. So I guess it would work like this, although maybe we'll change it in a while. So okay, let's get back to the actual drawing of our visible cells, and to do that we will use our camera. So we will not say from I equals 0, but we would say from camera dot x, or how we gonna do this? I think because we have a two-dimensional array, first we iterate through the row by row. So this should be right from camera x to camera x plus width, camera x plus camera width, or not pixel width but just width. And should we include this value? Let's say if we have 1, I think we should not, right, we should not. And for j, we're gonna, or no, the outer loop would work with y, so this would be y, and height, right, and the actual j would be camera dot x and camera dot x plus camera width, right. And we get these grid cells, and I'm just thinking about how to implement different like unproportional height to width, like if it's not a square. And yeah, that's pretty tough to do, but I think it's not really a problem, to be honest, because we don't even need the pixel height, we can just use pixel width as a reference. So let's say the number of cells that we will see is width. So we can say here that cell double cell width is equal to is equal to camera dot width divided by camera dot width. Camera dot pixel width, right, divided by camera dot width. And we should cast it to double first. And what do we get? We have how many pixels would we have in one unit, in one cell. So this would be cell width, and we can also say that it will also be cell height. So we can say it would be cell side, just cell side. And yeah, so if cell is active, then we wanna draw a yellow square. So draw new rectangle 2D double, and what we wanna say is we should have from 0 plus cell side times j, comma 0 plus cell side times I. This will be the coordinates, and cell side will be the side. Right, so this will make our variable yellow, our cell yellow, and we will also wanna create a square, a hollow square that would always be there to indicate that this is a cell. So regardless of a cell is active, we would also wanna g2 dot. So yeah, this should not be draw, this should be fill, because we want to fill the color, and the color should be yellow. So g2 set paint color yellow, yes, and g2 dot set paint color black, and g2 dot draw a new rectangle with the same coordinates basically. So yes, and I guess this should work, and let's try to use it. Let's try to use it. We can actually make this a static class because camera does not need to know anything about the outer member, about game component, but let's leave it as it is. What we should do is to set size of our component, and the actual size would be the same as the width of the camera, I guess. So yeah, let's say, however, we can say it 800 by 800 just to give it some space. Yeah, let's say set size, new dimension, and here let's say 800 by 800. Okay, and let's add this component to the main frame. So let's say add new game component, and let's start our main class and see what we will have here. And nothing is shown. I'm not sure why, but maybe it has something to do with the sizes and dimensions. Although maybe we have some problems with the camera. Yeah, I'm not sure about X and Y. Yeah, I guess we made a large mistake here. Or didn't we? I'm not sure. So we just iterate through some portion of the grid, and we draw it, and the coordinates here seem to be good, and I'm not sure why it doesn't paint anything. Maybe we should set not size but set preferred size, because you often encounter such problems because of size, not because of your code, but because of size. So let's give it a second chance. Still nothing here. What would be the problem? Maybe we adding it the wrong way. We can say add border layout center, but I don't think it will solve our problem. No, it doesn't. So let's see what could be a possible problem. Yeah, we could just debug it and put a breakpoint and see what happens. Maybe the logic is incorrect. So let's go grid cell side 30, 490. The J is very large. Oh yeah, now I see. So the I and a J that we use inside this calculation are very, very large. So what we can do is not use I and J, but use int I1 is equal to I minus camera dot y, and int j1 is j minus camera dot x. So this would be just a difference between starting point and the actual coordinate, and that should solve our problem, I guess. So let's change it a bit and see if it would work or not. Oh yeah. So basically we have what we wanted to have because there are no living cells. But the problem is we have those like cutted lines, and I guess it's because we should have a padding. So let's give it a bit of padding. Let's say here we would say camera padding, and let's give it a value of 40. So we would add the padding to the rectangles, not 0. What? Why do we have 0 here? Yeah, I'm not sure why I did that, but anyway, we can just change it to camera padding, and this should help, I guess. Yeah, now it looks better. So it will always show it like that, regardless of the actual number of cells. And let's try something different. Let's say not 20 but 30, and it should also show it all the cells. Right, cool. So it works. And what we want to do now? Now we want to have an ability to interact with the grid itself by clicking. There are several ways, although there are not many ways to do that, but there are several ways to approach that problem. But what I'm thinking about now is that we can actually start working with logic now, and then we can continue with visuals and clicking and interactable things, because we can actually now visualize what goes on with the actual game of life itself, with the actual grid. So we can leave the visuals as they are now, and we can start playing around with the logic itself. So let's get back to the Game of Life Wikipedia page. Game of Life. Oh yeah, and I remember that I accidentally put here not Game of Life, but Game of Live. So we should rename it to Game of Life. Okay, so now I changed the name, and let's get back to logic. So Game of Life by John Conway. So there are these 4 rules. Let's approach them by one. Any live cell with fewer than 2 live neighbors dies, as if by underpopulation. So the way we want to calculate it is to calculate each cell in our game, and for each cell we should check what will go on with what goes on with their neighbors. So if with a cell you have 2 neighbors, or fewer than 2 live neighbors, then we should somehow tag it as a dead cell for the next iteration. So we have, this is like a state machine. We have states that change every tick, and if we have a state, for each cell in the game we should calculate their next state, and after that after all these calculations we should change the actual state. So we should have some like a second 2-dimensional array that would actually store the results of our calculations. So the way I want to approach it is next. Let's say we have a grid. Let's paint it somewhere here. Yeah, I'm gonna use lines. So I've actually drawn these lines, and what we want to do. Let's say white are dead and yellow are alive cells. So I think we would have these edges. These edges would not have 8 neighbor cells like neighboring with them. So this cell does not have a upper left and the top left neighbor, and this cell lacks these 3 cells. So I don't think we want to calculate the value for these edges cells, so we want to start with the center cells. And let's denote that it is going to continue with these dots, just to know that it will continue to go these ways. So yeah, and we have this living cell and this living cell, let's say, and this cell. So we want to calculate the value for each of these cells. And for the first cell, for this cell, we want to calculate the number. Because it has 2 cells, it will be, because it has 2 cells, it will stay alive, because 2 cells ensure living to the next generation. So what we want to do is, so these first three rules are applying for the living cell. So if a cell is living, we want to just calculate all of its neighbors. And depending on that number, we can just denote what will happen with it next. And for the dead cell, we want to calculate the exact same number, but it has to have exactly 3 members. So how are we going to calculate the neighbors? We can do it just manually, just say if this has x and y coordinates, we want to calculate x minus 1, y minus 1, x, y minus 1, x plus 1, y minus 1, etc. So we can just manually change it. And yeah, to do that, let's go to our logic and grid. And first thing we want to do is to be able to initialize the grid cell we want to make some of the cells alive at the start. To do that, we can have a public method, public void set alive, just set alive, I guess. And we want to have the x and the y coordinates of the cell. And we should remember that this should start from 0. So yeah, and if they set it as alive, we can also add a boolean variable that would indicate if we want to set it alive or dead. So we can call it set or change state of. So change state of, and grid cells of x of y would have the alive logical variable in it. So that way we are changing the state of it. And we should also have a public method go to next tick, and this should be also void. So to do that, we want to iterate through each of our cells except for edges. So let's say for I, and I is equal to 1 less than size minus 1. This would be to 998. and for I, j is equal to 1, j is less than size minus 1. Right, and for each of these cells, we want to calculate the next state. So we're going to say Boolean next state is equal to calculate next state for I and j. And we're going to create this method. It would be the private method, private Boolean calculate next state for and int x, int y. And here we wanna establish how we wanna do it. So first, or not even first, we wanna just calculate the number of living members. So we can do it like this: for I for let's say j, or no, from I is equal to x minus 1, I is less than or equal to x plus 1, and we want to have an integer, and num of living cells is equal to 0 initially, and if grid cells of I and y minus 1, not comma but like this, if it's true, we want to add num of living cells, we want to increment it. Yeah, and the same should go for x plus 1, for y plus 1, and also we wanna do it for we wanna add the left and the right cells, so this and this. To do that, we would check the x minus 1 and y, and we would also check the x plus 1. Yeah, and this should work. It's pretty easy, I think. And now we want to say if grid cells of x and of y, if it was alive now and beforehand, then we want to create a switch expression, switch num of living cells, and case fewer than 2 live neighbors. So we can just say, even if num of living cells is less than 2, then return false. Or if the num of living cells is more than 3, so or num of living cells is greater than 3, then we return false. Else we return true. And else, if it was initially dead, then it should have exactly 3 members to be living, so we return num of living cells is equal to 3. So if it is equal to 3, we return true, and if it's not, we return just false. So yeah, this should do it, I guess. And we can even simplify. How we can simplify it? Yeah, we can just return this expression the negative part of it. Yeah, so if it satisfied this condition, then it's true and we want to return it as a false. If it's not, it's false and we return it as a true. Right. So we can even make it simpler, but okay, no, never mind. And yeah, we do it for each of our cells, and we wanna have an additional Boolean temp grid is equal to new Boolean size, and we wanna store the new temp grid of I of j. We want to store the new calculations there. Next state. Cool. And now we can change the actual grid cells. We want to say grid cells is equal to temp grid. Right. And now we are referring to the new what do you call it? To a new array, two-dimensional array, and it should work. But now, yeah, the logic seems legitimate, and we can now use the game component to change it. So let's say for the grid, like beforehand we established the states. Let's say for 500 and 500 it will be true. We would change it with clicks at future, but now let's just set it up this way. Just change some numbers, I guess, and see what happens. Yeah, this would be initially, and we want to have a button that would precede the calculations. So the button itself would be mainframe, and yeah, so we basically want to have a method that will proceed to the next step. So let's say public void to next step, and we wanna say grid that go to next tick, and repaint the component. This repaint will eventually call the paint component method, and it would be repainted, referring to the new grid, because it changes and now we are using it. Although, does it change? No, right, the grid itself does not, but the member of it changes, and we have an ability to get this member and to use it, because this member is just a variable, is just a link, a reference that we're setting up, and we get that reference, and I think it should work. Yeah, so now we want to create a button, and we want to say game component private game component, and say here game component is equal to new game component, and actually add new game component. And also we want to create a button, so JButton next step button step is equal to new JButton next, and next step button, add action listener, new abstract action. Here we can say what it should do, and it should just game component dot to next step, and this should work. And we should of course add the button, so add next step button, and let's say border layout east. Cool, so this should work, and let's see what we have. This is very interesting. This is very interesting. Oh yeah, next, and it seems it evolves. Wow, that's fantastic. That's really nice. I love it. I just love it. I'm not sure if it works right or not, but it works at least. So what we're gonna do now, if we have any time, I think we could make this video a little bit longer. But now what I want to do is to get the user ability to click the actual grids and to change their state. But the main problem is to get the actual cell that was clicked on. And we can actually do it, I guess. First things first, we should add a mouse listener. So add new mouse, add a mouse listener, new mouse adapter, mouse clicked, and here we wanna get the coordinates. So to do that, we can use the pixels. So let's say int click x is equal to e.getX, because e just refers to the thing that user did and they clicked, and we have these coordinates. And now we wanna do the reverse process of finding the coordinate. To do that, we can first say click x minus camera padding and divide it by cell side, and then we should add camera.x to it, I think. Yeah, I think so. So let's try. So let's say int x is equal to click x minus padding minus camera padding and divided by what we should divide by width, not width but cell side, right? By cell side. And how do we get the cell side? Cell side is this. So we want to have this here, and we're divided by cell side, and we want to get an int, we want to have an integer, so we can say let's just cast it to integer to get the floor of this number. And now we should say camera.x. I think it should work like this. So yeah, and let's do the same thing for y. Camera padding is the same, cell side is the same, camera.y. And of course it should be y. And now what we want to do is to say if x is less than, if x is greater than 0, let's say greater than 0, and x is less than grid get grid cells dot length -1, and y is greater than 0 and y is less than grid get grid cells dot length -1. Then we can change the state, so we can say grid that change the state of x and a y, and we can just, what's the problem? Yeah, and we can just remove this argument and say grid cells is equal to negative of whatever there is already there. So I guess this is a good approach because we can just get the current state, we inverse it, and we set it to this variable. So what's the problem? The problem is that we should just ignore these true values. And I guess this may even work. Let's try and see what happens. Let's see what happens here. Nothing happens. Nothing. Yeah, I think nothing happens because we haven't really repainted it. So after we change the state, we want to really repaint it. Let's see what happens here. Kind of works, but we certainly did something wrong. It's like it has to do with x and y. But what's the problem? What's the problem really all about is click y. I think I'm not sure what the problem is. So it really changes the different state, x and y. Yeah, because the x should be the second number and the y should be the first number. Because, or we can leave it as it is, I think, but we should, because x is second, because first number refers to the vertical coordinate. So this should be y and an x, and y and an x. Because this refers to the vertical and this refers to the horizontal. So we would actually get a different picture, and yeah, looks like it works. And let's say next, 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 and it looks like it's very similar to Game of Life, to be honest. And yeah, this looks fantastic. I mean, just look at it. That looks really cool. And yeah, so let's just test it on different Game of Life creatures. We can Google creatures and see. Oh yeah, we have on that same Wikipedia page different creatures. So let's make a glider. To do it, we wanna, let's open up our game. Let's get rid of these cells and let's see. I think it should be like this. I guess next. And just see, it evolves. Wow, that looks cool. And this, yeah, that's fantastic. So looks like the rules are pretty much correct. They are pretty much correct. Let's try something different. Decathlon. Well, actually I like something moving, because you have the static, yeah, spaceships they are called. Oh yeah, we can make this glider gun and see if it works or not. If we have enough space, of course. Let's just change the number of cells to 50. Yeah, number of cells to 50. So we will have more space. And yeah, and let's. Actually, I wanna change the color of the grid to something brighter, because it's quite hard to see. It didn't really help, but okay, never mind. Of course, yeah. G2, I just wanna change it. New, not basic stroke, but yeah, basic stroke, and here we wanna say width is equal to 1.5 f, and this should help. I think it didn't really help. Maybe 1.1 f. Yeah, it does not really help. Okay, anyway, let's create that glider, or what do you call it? Yeah, glider gun. So first thing is to make that square. Okay, looks like I finished, and let's see if it works. Looks like it does work. You see, it produces those gliders, and yeah, for me it just looks fantastic. It just looks cool. So what we want to do is to change the coloring, because it's really getting in a way. So let's say color that light gray, and for yellow we say dark gray. And let's see if it's better. Yeah, it's certainly better. So yeah, we can just now play around with this, and it now starts to work. But the thing we want to do is to be able to change the size, to move the camera, and to be able to see how it evolves without us clicking to the next button. But anyway, it works already, and we can see how beautiful this is. Just look at this. And yeah, there is pretty like many work to do left for us, pretty much work to do, but the logic itself is established, and for me it just looks cool. It's really cool. Yeah, just look at this. Wow. Yeah. Yeah, just how cool is this? Just look at this. Oh man. Yeah, how could human come up with this? Yeah. Yeah, this is just gorgeous. I mean, wow. Just look at it. Come on. This looks cool. Okay, so yeah, eventually it's dead now, but this is really cool. So guys, thank you for watching. This was a very cool video. In the next video we're gonna polish our game. We will work with zooming in, zooming out. We will change the overall look of our game, make it more beautiful. But for now, we made the core thing about our game, and for me it's just cool, cool, cool. But we have pretty much work left to be done, but we will do it in the next video. And so thank you for watching, guys. Write some comments below in the comment section. Press a like button or a dislike button if you don't really like the video, though I don't know how you may not like the game of life, but maybe you just don't really like the video as it is. But anyway, thank you for watching. See you guys in the next video. Bye bye bye.